Hi there guys, and welcome to part 10 of this series of videos. So in the last parts, let's have a quick look at where we were. So we're still looking quite red at the moment. Interestingly enough, what we're trying to do here at the moment. So last time we were trying to get rid of the generated tests. So we've done all the hard work. We separated generated tests and manual tests, and we just had generated tests running on their own. So whilst you guys were away, I actually removed all the generated tests, and I also removed all the test data and any other features that were being used only by the generated tests. I pushed that, and I was hoping at something new here, packages, and I was hoping that we'd see some green builds actually. Instead we got some red builds. So okay, so the good news is the bulk of the work has worked. We now have got everything compiling and in good time, 10 minutes to spare in most cases. It tight still in Clang, funnily enough, on OS X. It's actually quite surprising, given we're compiling a lot less code. But most importantly, we're red on Clang. Let's try to understand why we're red. 100% of the test passed. Okay, not obvious why we're red. Let's have a quick look at what C- things happened. Let's just log in so we are viewing what we should be viewing. So if I go to Dogen, this doesn't look too bad. Here's our Clang 8 debug and release. It's actually slightly puzzling as to why Travis is convinced that we are failing. Sadly, there's always no, not quite what we want. We want project home. Let's try to understand why Travis is so convinced that Clang's failing. So the building itself looks pretty good. User bin CPAC not found. Most peculiar. So we seem to have failed to generate the package. Right, yeah, that makes sense. It only happens in Clang release because we only generate the package from Clang release. Okay, surprising. I think we are manually installing CMake, so this is the interesting life of a developer, really. It's as soon as you've finished with one problem, something else will surprise you. Clearly not what we wanted to be spending our time in, but there we are. Right, so let's just make sure that CMake. Here we are, CMake. There we are. Okay, so CMake to cmake.org really is not happy. So for a laugh, make sure CMake is alive. Looks alright. So what I'm going to do is I'm going to cheat slightly. I'm going to say, can you just restart this job? Hopefully it will be quick. No, hopefully we are just restarting the one missing job. Okay, cool. Interesting that oh, so this is the second time this problem has occurred. This time was something to do with Travis. We are actually being a bit unfortunate at the moment with builds. Now that shouldn't take too long, hopefully. While we wait for that, we can have a quick look at the Windows side of the world. still a few tests failing. So in Windows we are slightly happier, but not quite there yet either. So redness on Windows. Okay, that's not a problem. So I'm not entirely sure why this build's failing. So again, have a look at C dash. We should have probably looked at the name of the build. Okay, right, it's possible it's to do with the test. We have one build, so CL release. We seem to have a lot of failures in CL release. So if that's the build, then we know it's just a unit test. So that's also okay. Nope, not quite that. Nope, it's actually MSVC. Well, that's interesting. Why does AppVeyor think MSVC is failing? Okay, right, so some error with our boost tests machinery. Okay, cool, this is just Klaus's little project. It's basically, if I just show you what this does, is Klaus has just created this overview of all the tests that we've got, and it shows you tests that are failing per test suite, which is quite nice actually, and it gives you some nice overview. So it seems like we have some kind of problem communicating with Klaus's stuff, so we're not going to worry too much about that. Okay, right, so with the last set of commits, as you can see, the build times have gone down, and mostly now we've got all builds actually not timing out, which is what we wanted. All these builds are now becoming green, so that's really good. In addition, of course, as you remember, we also got all these builds for the reference implementation going a bit greener as well. Similarly, hopefully similarly on Windows. Still looks a bit red. Not sure why it's so red. Okay, we have errors on Windows. This could be okay. Let's just make sure that, because of course we are aware that some of these tests are not passing at present, so that's expected. Let's just make sure that's really the test we are expecting to fail. Yeah, that's correct. Okay, so as you can see here, oh no, actually that's not okay at all. Spoke too soon. In fact, we don't seem to be getting any Windows builds just yet coming through. These are from yesterday. But as you can see, there's quite a few errors coming through here. So we probably should do a commit on the reference implementation today, just to make sure we get all the Windows and OS X builds coming through. Let's get this thing to stabilize. So anyway, all in all, what we're trying to say here is we have managed to succeed in our little experiment in trying to reduce build times by removing generated tests, which is one half of the job. The other half of this job is we need to generate a nightly build that runs all of the generated tests, because you can see there was a massive drop at the moment in terms of what's being tested. The other thing as well that I mentioned before was we were relying on the generated tests for coverage. Now I spent some time thinking about this, and actually it's almost like we need a split view of the world. On one side of the world, yes, of course generated tests are important for coverage, because we want to make sure that all the code that we generate has some kind of associated test with it. But what we don't want to do is we don't want to generate some code and then generate the coverage for it and then actually not use that code in the main sort of tests. In other words, if you generated some code, it should be for a reason really. So we don't want the generated cat tests to hide the fact that we're actually not using that code anywhere in our tests. So we need two different kinds of coverage tests. We need the coverage test that we have for generated code, and then we need the coverage test that we have for non-generated code. Interestingly enough, we don't seem to be updating the coverage for CodeCov. I never really liked CodeCov, is a bit strange. Coverall seems to be a little bit more reliable. Let's see what the last commit was. Also 4th of September, interestingly enough. So it seems we haven't been updating our coverage. So that's a bit of a problem. Not quite sure what that is actually, so before we do anything else, let's just make sure we well, actually, first thing we need to do that we haven't done yet is pull latest. For some reason git, oh sorry, fetch. Okay. We are not looking at the correct git process. Sometimes this happens. Version master. Right, there we go. We just did 3 pulls. And now you can see the latest commit. Rebase from master. There we are. And if we now do build, go up to. Right. Okay. So then. We should really, once we've got green here, we should really have a story to talk about this problem with coverage. Code coverage has not been updated since September. For some reason, we have not been generating coverage reports for a couple of months. Okay, so this is now captured. I'm not going to look too much into it right now, but we definitely need to look into this. Once we got the coverage up and running, hopefully this will, well, what we're going to see is the coverage is going to drop dramatically, as we'd expect, because of course some of the coverage is actually generated tests, and the generated tests in a way are hiding the real coverage. So we do want, so going back to what I was trying to say before I got confused with this coverage thing, we do want generated tests because we want to make sure that the code we generate has got some kind of basic sanity tests that validate this behavior, and that's fine. And that's a Dogen sort of test that's required, just like we have that for the reference model. However, from the perspective of Dogen as a product, we don't want for the generated tests to count to coverage, because we want to have coverage of the functionality of the product rather than code-generated code. So we need 2 different coverage reports: the generated code coverage, which could include other tests as well, and then we need just the regular manual test coverage. And so, since we've already got 2 different code coverage platforms, we could probably just export the tests. We could export the code coverage to the different providers once we figure out why it's not working. So we will look into that in a minute once we've got a way of generating the builds for the generated codes. We haven't started clocking yet. What we should say is that we spent some time, so probably from 21:05 perhaps up to 21:20 perhaps, just watching and setting things up and watching the videos from yesterday, make sure they looked alright. And then from 15 probably, 15 or 20, sorry, we have been, well, to be fair, what have we been doing? Well, I'm just gonna clock this against history. It's not exactly right. To be fair, clocking is not exact science. All you want to do is you want to make sure that you have some vague idea where you spend your time, so that when the end of the sprint comes, you can figure out, you know, you can do a post-mortem of the sprint. So so let's just think about this for a second then. Where we are now is we're trying to figure out how we're going to run a nightly build that takes into account generated code. And so we had a couple of ideas about this. I mean, we could create a new branch, and the idea is that we create a branch just for nightlies, and the idea being that you pull master, you run using overrides, you run the code generator, it will generate all facets everywhere. And oh, most interesting, seems like a tag following error from Trimax is returned. I spoke to Alexander Miller and told him that everything was working fine, but perhaps I spoke too soon. See if this is just an org mode problem. Yeah, seems to work fine outside of org mode, so let's just return to Agile. See, okay, that's interesting. Okay, let's just submit this to Alexander, so he knows. So we just go to messages. Sorry for yet another. Sorry, I meant to go to messages in Emacs. So let's just mention this to Alexander Miller, because like I said before, the Trimax developer is really responsive, and because of that I think it's also nice to be a nice user and keep him up to date when problems occur. Alexander, Trimax, the fixes you push have worked really well for C++ mode, but I just noticed I still see similar error messages when I am using org mode. And then if you just say I don't have LSP for org, so I'm not too sure. Well, actually, let's just not mention that, because he probably knows this. I wonder if these errors are related. And the other thing as well that Alexander has asked in the past was to run Lisp commands which is this guy here. Sorry for the big parentheses that we're opening here, but I mean, it's part of the job of an open source developer to help other open source developers. I mean, they already are contributing with code, so if I just say sprint 19.org, that's the one. Now, and if we just attach this to the report as well. The Lisp, let's just see. You could just say then, seem to still have some remnants of problems with multi-parents. Running Trimax and Unix results gave me the following output. Okay, quick preview. Okay, and so this would allow Alexander to continue his investigation. So this is really part of the work of being an open source developer, is to look after the ecosystem really. Now here what we want to do is return to project backlog, and I think the division, no, it's actually about the right size. Look that they're not right the sizes, but perhaps it's just me. Okay, now then, before we got distracted, so we were talking about how we need to somehow create a build that uses the override functionality that we've created to generate code across all facets. Now we've had a number of ideas of how to do that, and so one idea was to create a branch, and the idea is that you create a branch every day, and then, well, you check out that branch. You create a new branch. Sorry, let me just recap what I thought about doing. So you create a new branch, you run the generate all dia models with the override, so it generates every single facet. You commit that branch, and then you push, and then the nightly runs off the branch. And the next day what you do is you delete the branch, and the same thing happens then again. Now the problem with this approach is that because we keep deleting the branch, it's not so easy to go back and see what went wrong with it. Something has gone wrong. We could also have a Monday branch, a Tuesday branch, and so on, and then just loop around every 7 days. At least that will give us a bit of a window of time. So but then the problem is we have to manage this window of time. The other idea is we still have a single branch, but we use Git to manage this flipping backwards and forwards between master and the generated code. And finally we have the idea of not committing at all and just having local state, and then if there's a problem you have to go to the build machine, which is the main machine anyway, and see what's going on. So I think the best way is to actually try it first to get this to work with a single branch. I'm not quite sure if this is gonna work or not, but I think it's worth trying. So in this following this approach, what we've done is we started creating a script. We probably should rename these scripts because as you can see here, it's very hard to find the scripts. I wonder if I forgot to push the script. Sure, should have been. Well, let's have a quick look at the commits. Okay. I think the problem is I didn't push. Let me just have a quick look at my trusty old laptop, which I use in the commutes. I think we may have a commit that we didn't push. It's a very clever rotation it does to the screen. It's been a bit of a haphazard experience tonight. Lots of assorted problems from Tremax to everything else. Now you can't see what I'm doing here, but don't worry, because hopefully the push will be very quick. And yes, we do have things that didn't get pushed. Alright, so I'm just gonna quickly push here. And the push is done. If we just switch the laptop off. Okay, this is the life of developers that need to code in their commutes. Though having said that, Git does make life much easier. In the past we had a number of problems. Now with Git it's very easy to keep things in sync across multiple machines. Right, so what we'll see, if we have a quick look at this commit, is a number of scripts as you're seeing here. And these are the scripts we want to have a look at now. So let's have a quick look at local git. Here we are. There's a master. Oh, sorry, bit too quick there. I think git was not happy. Rightly so, because we forgot to stash. And now we're gonna have some kind of problem. And the problem probably is with just the clocking. So we will just say, well, it doesn't really matter. We will take upstream, manually merge it. Must confess, I never really learned how to use S-merge properly. It's a very good mode, but it's not the easiest to use. Now I think we got arg mode in a bit of a tangle. Let's just right, so okay, right, where are we then? Okay, that all looks good, and if we resume our little experiment, so as you can see now, so what I was trying to say a second ago, before I was rudely interrupted by the fact that my scripts are missing. This chair is also not helping. I think everything's against us today. We have scripts here that we just created very quickly to just get something going. I was just having some thought experiments in the train, and so I created this generate.sh script, which is literally just some very basic thoughts that I was trying to stitch together. What we really want is a script that goes to the remote, clones it. Now you see here we are cloning with a name of generated. We're just setting max depth to 1 because I don't think we really need the whole history. We enter this directory and then we check out the branch. In this case it's generated_code, and I just call that just to avoid calling it generated, so that everything is called generated. Then, well, my idea was to say, well, if there was a commit that was done before, and that commit matched some commit comment, then we would want to revert that commit. And the idea being that every time you do a commit that's generated code, you can mark that as, I don't know, generated code, say, and to avoid spurious clashes, conflicts with master, we just revert back to the state as it was prior. Once you've done that, you can just git merge into the branch, and then you could git commit the results of the merge. That's also something that we need to see. And then once we've done that, we can then do the actual steps of building a code generator, generating the models. Of course we need the override here, and then we git add the results of that, we git commit that, and then we push to origin. And then the nightly, of course, will trigger off of the generated code branch. And then it will look as if the nightly is exactly as it is at the moment, which is what we want. But in effect, the nightly is executing off a branch with all of the generated code. That all sounds very sensible. So let's just do some experiments with this and let's see what happens. To make life easier, we're just going to clone from the local repo, because we don't really particularly care about this. So we don't really have to put some load on GitHub for no reason. So let's say that the git commit message contains the string generated code. And let's do this little experiment here in our shell. Something like git log. So let's just say git log last commit. Obviously a common thing to do. We just want to see the last commits. Okay. So we try something like this. Okay, this is another classic git emacs. Right, that's very good, and you can see that the comment is here. So you can then say grep for I don't know. For now, we could just say scripts start, and we probably should have put right. So that's quite nice, isn't it? I mean, we could easily say with this, we can easily say if we match this, and perhaps what we want is something like the return status, so dollar question mark dash return status. So Lord, we need the easy version of this. Here we go. And we could easily do something like right, so we execute these commands. I'm just gonna call this red because I'm lazy. We'll just put some comment like this, not found. Well, in fact, we probably want to say if red eq 0, then found, something like this, right? So we're basically saying, well, if you found this commit, then do something like that, which is good. And then we want to say git revert last commit. So to undo the last commit, okay, interesting enough, we've got the commit hash there as well. So we want to but this is to undo a specific commit. There must be a way of reverting just the last commit. I mean, we know what it is. Why do we need to a bit of spam here? It's interesting how we right, so we just want to undo the very recent commit. Undo a commit and redo. No, this is a bit too hardcore. We want to actually revert I think we want git revert. Okay, excellent, that's what we want. Git revert head. Now the question is, does it actually commit? Similar to merge, revert to create a new commit, which will open up the configure system editor. Okay, excellent. So then we can now say -m revert. Now we have to be very careful not to include the string generated code in this message. So revert generation. So this revert generation should not string match generated code. So for every commit we'll have two commits. For every run we'll have two commits. One that commits the generated code and one reverts that. And then after that we will merge the master branch. Now it's important we're merging, not rebasing. And commit -m. So I wonder if you can git merge and commit, because we don't really want to git merge other branch -m commit message. So merge master, to merge master. auto revert, so we know this is meant by the script. And here we could say well, generated code is probably fine, I think. Okay. Oh, this chair is actually really becoming troublesome. Let's spend a bit of money with a half-decent chair, I think. So where are we then? We're drawing the build script as we always do. Of course, one thing to bear in mind is the build script doesn't do any overrides at present. So we need to understand the overrides logic. Let's have a quick look at. Right, so we had these variability overrides here on the Dogen processing objects options, but we never bothered to actually create a with overrides. So perhaps we should say something like with full generation. And here I want to say something like generate all facets for all models. And when we have full generation enabled, what we want to do is we want to say if with full generation we like to set when full generation is enabled, we would like to set the profile. Okay, so that's correct. In fact, we'll just for now, just for a laugh, we will. No, actually, to be honest, it doesn't really matter. We'll test with all of these. So what that will do is we'll do the override across every single model if you've enabled full generation. Now, then, if you go to the build scripts again and look for the Linux one, of course, no one is using this option. So what we want to do is we want to do similar to what we've done here. Is we want to say, well, if somebody sets some environment variable, which could actually be called exactly the same thing, really. No, actually, to be honest, maybe we should just call it Dogen full generation. And then we could say here, well, if somebody has defined that, please supply the option there we go. So if you supply this environment variable, it will go and it will do a full generation. So hopefully what that would then mean is one thing that we're going to have a problem with is we've removed all the generated tests. So we probably, this is becoming more and more complicated, we need to check whether the generated test directly exists or not. And if it does exist, we need to pick it up. Because we're going to create all the generated tests, but nothing's going to happen because we didn't check for it. So in this branch, it will exist. So we need to go and pick it up. So we need CMake to detect the presence of that directory, and if it exists, include it, and if it doesn't exist, don't bother. So well, we'll leave that for now, because that's actually an easy thing to do. And in here, what we'll do is we'll export this chap here. One seems like a sensible value. And then we will run the build. That will do nothing. It'll build, but it will do nothing in particular. And then we will generate is actually generating with all the files. Then because we do git add -a, we add every single file, then we do a commit to the commit message, then we push origin. Okay, so this all looks quite good. So what we'll do is to test this in some kind of step-by-step sort of way. For starters, the git branch may not exist. Check out. So if we just do git checkout create branch, I believe it's -b, but let's just double check. Checkout -b, yeah, I'm pretty sure it's -b. So if I just say git checkout -b, I believe if it doesn't exist, it will create it. And then if we do a git set upstream on push, well, I think it's just in git branch. So if we just set upstream on git branch, we don't have a git branch command. Let's see if it's possible to do a push. Git push set upstream. Yeah, okay, it is possible to git push set upstream. It's probably going to actually create the upstream as we speak. Let's look at the shape of the command. Yeah, that looks pretty decent. Okay, cool. So what we've done then? No, I would not want to do all of this in one go because clearly that's going to be an absolute disaster. So what are we confident about? Let's just test. Oh, I think I'm going to remove these comments and then we comment this out properly. Comment the script properly. So I'm just going to be comment region, and then the other thing we can do as well is since we already have a shell here, we can work on the shell script next to the shell. Right, so then, so this is designed to run somewhere like here. In fact, it's designed to run where the nightlies are. So that's what we'll do. So let's just grab the path for the script. Choose this chap here, and then we'll just go up to nightlies, I believe. Right, so this is where we run our nightly, so let's see what happens. So okay, this is a little bit aggressive. But it seemed to have done the trick, so let's have a quick look at... we don't seem to have a generated directory, that's a bit worrying. Where exactly did it clone? Work, integration, build, GCC 9. Okay, so it's running the scripts on GCC 9. Okay, right. I know what the problem is. We are running build.sh, but we should be running generate.sh, okay? So that's the first problem. Permission denied, so if we just chmod plus x. Right, cool. So max depth is not a git command. No, it's just called depth. We're confusing this with some here, I think. Okay. So minus depth is ignored in local clones. Alright, let's just call this file // whatever that means. Right, okay, so that's interesting. So clearly you can't git clone if we already have directory. So perhaps you can do something like do we have some example? Yeah, here we are. You can check if the directory already exists. So if not, so we can create a variable here called generated, perhaps. If the directory does not exist, then we git clone. And for the measure, we just use this variable here. And then we cd, and we check out. Okay. If the directory already exists, well, most likely we already are in the branch, aren't we? No, to be honest, just to always be on the safe side, we cd into the directory, we check out the branch. Let's try running this again. Okay, interesting. It's because of the -b, really. So what we'll do is we will just say, for that particular case, we -b, but for this case we don't -b. Okay, good. So at this point in time, we... Oh, sorry, forgot to... oh, this annoying... it's really rather annoying why Git doesn't... always attempts to do this pager thing. Okay, we are in generated code now, so that's good. Now then, so if we attempt to check whether we are in this commit, and then perhaps we just have an else and just say echo not revert and commit. And we can just do a quick test with this. So let's run this again. So not revert. Oh, it is attention. Integer expression expected. So if presumably we. Okay, good. So we're not reverting the commit. So now what we're going to do for good measure is you're going to go to this generated branch. You're going to change something like, I don't know, remove a whole lot of stuff, and then we're going to say commit. As you can see, we generated code, so we're going to commit. We're going to call this generated code, and then we're going to go back to the shell, and we're going to run our script. Now, see, we're not reverting the commit, so that's clearly a bug. So let's try running our little command here. As you can see, most interesting, it doesn't seem like we're grabbing the git output. So perhaps there's some kind of redirect going on here. So let's just try to do it to &1. Interesting. Notice that we said $commit message. So let's just replace this $commit message with the actual commit message. And also notice that we didn't put a dot. Okay, excellent. So let's try running that again. Not too bad. So that seems to have done something. So option mainline expects a number greater than 0. Right, so well, as always, we should just try to run the command manually. So git revert head option mainline. Okay, not entirely sure what that means. Ah, okay, obviously oh, so presumably minus m doesn't do what we thought we did, which is it's not a message. So what happens if we just say git revert head? Okay, so minus m test. Oh, to be honest, nothing wrong with our original. Oh, let's try that. So I think this is actually a git bug. I think what's happening here is git. Oh, look at that! Git the no page is not even working for this. We're really having a bad git day today. So minus m main line rather than the commit message. Can sign the commit. We don't seem to have a way to give a comment for the commit. When I merged and committed, I did use. Okay, right. So, but this is not a merge commit. So, right. So this is the problem we had before. So it seems that it's not actually possible to revert. Supplying a message. Slightly sad with this actually. Oh, perhaps no edit is what we're looking for. What does no edit do? Alright, let's git status to see what the local changes are. Ah, okay, this is possibly because we are halfway through fixing this, so as you can see git revert started reverting but didn't commit. That's fine. So what we'll do is we will just okay, excellent. So let's just update our command here to say git revert no edit. And that should actually revert the commit. Now as you can see here, it just basically says revert generated code. Now this is a slight problem, because as I said before, we definitely don't want to be picking up the revert, otherwise we'll be reverting the revert and so forth. So all we want to see is a pair of commits and reverts, otherwise this is going to end up very messy. So what we need to do is we need to ensure that revert is not on our grep. So grep minus v revert. So now if I run that script again, and this guy here is not reverting the commit. And now for good measure, let's just go to generated and let's manually get rid of that commit. Discard. So now we'd like it to reverts. And as you can see here, in this scenario, it happily reverts the commit. Okay, so that's good. So we managed to now somehow revert the commits as long as it's got the word generated code in it. Now what we'd like to do is we'd like to merge master. Now we'd like to merge master again in commit. So git merge and commit. No squash, no aborts. Well, let's see what happens if we just simply attempt to merge. Slight problem, of course, is that we don't have anything in master to merge, so... But nothing stops us from creating a fake commit that we're not going to push to GitHub, so... Let's just go back to our actual master. This guy here. And in here, we'll just make some really silly commit. Let's call this fix me don't merge. Now merge, you see we can merge this to master. Well, we committed this to master. We'll make sure we don't push this, of course. And now what we want to see is what happens when I try to git merge master. So what we probably want then is something like else. So we want to go into the directory, either case, and in this case we want to do git pull origin master before we do anything else. Right, so hopefully at this point in time origin master. Oh, interestingly enough, we don't really have an upstream here. So we did the git clone. So we probably want to do something like git remote add whatever that was, and we can call that origin. And then we check out the branch. Okay, so let's just test this script. In fact, to be honest, let's just, before we do that, let's just not bother with merging master. So what we'll do now is we will see what happens if we run the script from the beginning. Okay. Perhaps we need an extra... yes. Okay, so now what? So this cloned. So what we forgot to do is we forgot to say go into the branch. Right, so this clones. Okay, so orange already exists. Interesting. Okay, presumably we can't do depth equals 1. Let's make a depth equals 5 maybe. And not reverting commit. Okay, cool. So that's not too bad. Okay, let's try this again then. Yet again, a lot of this is just going to be iteration a few times. Right, so what we got then? So it cloned. Apparently we already have origin, so okay, fine. Let's not add origin then. It's switch to the branch. Now because we've got these two paths, we can just do that. Right, let's just test this one more time, just to make sure that we don't see any CD errors. Okay, good. So that didn't revert the commit, which is what we'd expect. So now, yet again, what we're going to do is we're going to go into this guy here. Now I'm going to do a few tricks here. The first thing is, let's drop the non-merge commit. then let's add. Oh, I can't commit because there's nothing to commit. Let's go here and just randomly change something, and then let's commit that. You probably want to call this generated code, and then let's go to master. Any master, let's drop that commit as well, and then we could just stash it. Right, so now, the setup at present is we are short one commit from master, right? Which is the commit we want to test. And what we expect to see is, this path taken, where we pull origin master and then we check out the branch and the commit gets updated. So we'll just run the script again. And what happened here was we pick up the missing commit, we switch to generated code, we revert the generated code, and lo and behold, we're just missing the command that we actually wanted to run, which is we're just missing the merge master. So we're exactly where we want to be. So let's just quickly go to this branch and say, what happens if I try to merge master? Okay, that's good. And then we'll just steal this chap here and try running this again. We haven't concluded our merge. So what we'll do is just let's just go to my git and let's just say merge abort. Yes. Right, so now we're in a good state. Go back to shell, and now we just merge master. And then what does this say? Right, so auto merged master, and this is a merge commit that contains a change. And this, of course, will contain a whole lot of changes if we were in a normal day, right? So after we merge master, and this merge should always work because remember, we've pulled latest, we checked out the branch, so we're now up to date in master. We checked out the current generated branch. There's only one commit that ever goes into this branch, and there's only the revert. Well, there's only two commits: the commits with the generated code and the reverts of that generated code. And then we just merge master. So once that's done, then what we do is we basically say, okay, can you please build. Now remember, of course, at this point in time we're inside of the git directory. So can you please build Linux Clang as quick as you can? So let's give it a 6. And then can you please generate all? And 6 will do. And can you please git add, git commit, and now this is where we have to be slightly careful. Let's not git push, but this will be a bad thing actually. All this will do is will generate a new branch. Well, let's just test that locally, I guess, better than testing with GitHub. So okay, let's just do a quick test and see what this does. I mean, this is all rather experimental, but it's exactly the job we're trying to do here. So we fire off the generate script. It's going to do a git clone. It's going to create a branch. It's going to check out the branch. It's going to see whether it needs to revert or not. Then we'll merge anything from master. Oh, interesting. I wonder what would happen if there's nothing to merge from master. Let's see what happens actually, because I reckon it's going to give us an error because there's nothing to merge. So presumably there'll be nothing to merge, sort of syntax for git. So okay, let's just run this and see what happens. Okay, this is good. Okay, so what we've done here, sorry, let's just monitor I've generated again, and let's go back to this chap here, and let's drop the fake commit. We don't need that either, so we're gonna discard. Right, so now we have a good state, and if we go back here, we deleted everything, we start again. Now, interesting. Okay, so now the problems we're having at the moment are just to do with the fact that we haven't actually prepared our environment properly. So what we'll do is we just have a quick look at our nightly, and in our nightly, you'll see a number of things being set up that are needed in order to build. And what we need is to make sure we have those things set up as well. I mean, this is obviously not production ready script, but right, so that looks a bit, 946. Okay, quite expect that we needed 946. Let's make sure that we're actually running the right target. So, a bit larger than I expected, to be honest. Perhaps we need to disable a few things here. Although, to be fair, I mean, Dogen CLI does depend on pretty much most of the code that we got in Git, so maybe it is actually quite right. It's about right, maybe. Let's have a quick look at what it is doing. It's been a bit of a long day, so this is a bit of a rambling video, but I guess this is also a very good way of demonstrating what the reality is, really. Interesting. We seem to already be linking Dogen.cli. But it's only the lib, of course. Let's have a quick look at what that Dogen.cli was. Yeah, we are linking the Dogen.cli lib, and I think we build a lib and the exe, so that's probably alright. So it is a bit sad that we have to build so much, and then we have to build all over again after we generated the code, but I mean, as with everything in Dogen, this is really not going to be the perfect solution. We're just going to do the quickest possible thing that needs to be done to get us going again. So, and then we're going to write some stories on the back of this work and say, okay, we need to revisit this and clean this up. Provided that we are running all the generated tests and we're generating reports on the back of these generated tests, this is good enough for us to move over. And then at some point in the future, when there's another kind of problem, we will have to revisit this and do some more elegant solution. Unfortunately, this is how this development works. In fact, while we wait for this, let's have a quick look at oh yeah, this is much better now. As you can see, everything's gone green. So the other thing we want to do is, now that everything's gone green here and everything's gone green here, we want to remove all of the allowed failures, and in fact probably even further, we want to see what Windows is saying as well. If Windows is also looking, sadly we're building Dogen and that takes a while, but if we have a look at projects, we seem to still having this redness on MSVC, which is still not entirely understood. I think we'd have to download the log and have a look at the errors here. Meanwhile, we're getting closer to the end of this build. problem with the Windows logs, to be honest, is that oh, we have an error. Okay, so nothing to commit, work tree clean. Okay, that's good. So well, that's not good, but let's see what happens. And the work tree is indeed clean. Okay, that's good, that's good. It means that we have a problem with the overrides. So let's try to understand why we have a problem with the overrides. Likely, I think I know what the problem is. We did all sorts of clever work here, but we never did commit all this clever work. So we need to get master up to date with this. Let's just basically say something like make scripts handle build overrides. Let's have a look at diff again. Handle full add option for full code generation. Something like this, right? So now we have an option for full code generation. Now what we'll do is we merge that into master, and we return to our little experiment. Of course, now you can see that we don't really want to be deleting and restarting from scratch every time, with 900 translation units being created every time. It's a bit painful. But hopefully this is a test of where master got updated. No commit exists yet. And that looks much better. Okay, so we still have a problem, but so as you can see, we did a pull of the code that we didn't generate, and I'm pretty sure we did a commit correctly. We generated code on it. It's going to be a very large commit. As you can see, very large commit because it generated all of the files. So that's very, very good. What is not so good is that we weren't able to do a push of this into master. So what we'll do is go back to shell. And then so updates were rejected because the remote contains work that you do not have locally. This is usually caused by another repository pushing to the same ref. That's interesting because I wouldn't have thought the remote has any work that we don't have. So I think there's some confusion going on here. So as you can see here, our latest commit to this remote is cmake scripts. I wonder if it's because the branch doesn't exist. Perhaps we have to create the branch first, actually. Oh, and there's another problem as well, which is one has to bear in mind that we didn't rebase the branch from master. So, okay, let's look at this again. So, our generated code branch. Right, let's just make sure we're not attempting to do something really silly like push to master. And the other thing as well is we're using git work tree, so I wonder if that also has an impact. But okay, sorry, before we get the best confuse one issue at a time. So if we look at generate.sh, we are definitely doing a git push setup stream origin git branch, right? Now, generated code must not exist at present in our so if I just do branch, well, it used to be branch view, but they keep changing the shortcuts. Branch. Interesting. It doesn't look like we can just see the local branch. No. it is actually not trivial to view branches. It used to be quite a simple thing to do in my Git, but not anymore. Apply branch beside commit and diff. Fetch pull log merge blah 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 revert apply. So not a simple thing as you'd have thought. Local branch. Rather interesting that we can't do. So my git show branches clearly. Okay, make it so refs. Thank you very much. Right, so now it shows all the refs. So interesting. Generated right. Okay, right. So right, this is fine. We just ran this script before. So what happens if I try to get rid of this branch? Yes, please. Right. Okay, cool. So this is just because we ran this while we're testing. This is perfectly acceptable. Now, just for a laugh, what we're going to do is, because we haven't pushed this branch yet, nothing stops us from saying in fact, what is going to happen if nothing has happened from one day to the next? So in other words, if I do a git pull, this is the problem unfortunately with these scripts, it starts very simple but there's a lot of permutations. If I do a git pull and yesterday there were no commits at all to master, the last commit is going to be a revert. And then we will attempt to generate, nothing will have changed. Oh, actually this is a very good test. What happens if I just rerun this script? Okay, that's fine, it reverted, which is what you expect. And then it builds, because we changed so many files, it will always build. Sadly we don't have to wait for a long time, but this still makes sense, right? So what we're trying to say is, because there is no revert commit, it has to revert. It will leave you in the state where master is right now. Well, where master would have been anyway, so that you're ready to merge. This is actually quite a complicated thing to do, I mean, but that's fine. Part of this story was to experiment and see how complex this is. Clearly this is not the easiest solution. We might have to reconsider. And it's already half 10, so let me see what we can do for the next 40 odd minutes. This has been probably one of the worst episodes of this series. Hard to believe really, because we've had quite a few wild goose chases, but today has been even more of a wild goose chase, it seems. So just to recap, what we're trying to do at the moment is we're trying to see if it's possible to just create a very simple, in quotes, script that creates the, well, has its fairly clean branch, updates that branch to the latest in master, generates all code across all models, and commits that. And then that branch will be used as the basis of our nightly build, because it will contain all of the generated code. And the reason why we want to create a branch is just so that we can keep track of the generated code. So that if the nightly breaks for whatever reason, either the tests didn't work, or there's like a Valgrind regression, or whatever reason, and there's an investigation required, we have perfect traceability because we can see exactly what nightly saw. We can just do a checkout of that commit, and away we go. Now of course this branch is a completely private branch that's only used for this purpose, and it will only be used to run the nightly, and we can just drop this branch up whenever we want to, and restart again. However, we've already seen that there's quite a few permutations here. The clean case of there's no branch, the case of no changes at all in master, which we're kind of testing at the moment, the cases where there are changes in master, and so forth. I mean, we will test this over time as well, because once we integrate this with the nightly build, we will see all the permutations coming through every other day. The sad thing, of course, is that every time something breaks, we then have to spend some time trying to remember what we were doing at the time. And this is never ideal, really, especially when we haven't got a lot of time. So we're approaching the end of our builds. And of course, the reason why we're building CLI is because oh, interesting. Oh yes, of course, we'd always generate. Yes, that's correct. Actually, we would always generate, because of course, remember, these files are not in master. So even if there are no changes whatsoever in master, we'd always revert and recommit. The reason being that we need to retrieve, because we reverted. So okay, we could be clever here and say, if the git merge master didn't do anything, so if I just look back to what happened here, what we want to know is, did we actually merge anything? If the merge is a no-op, then there is no need to proceed, really. Right, there we are. So as you can see here, this is the grep, and because we found generated codes, we immediately go into revert, and sadly we can't do that. We can't check if there's any no, we can't check if there's anything in the merge, but we can check to see if there's anything in the git pull. So if I just say something like generated git pull origin already up to date, is there any way? What we can do is we can grep for already up to date, right? So if we are already up to date, we could say, actually, don't bother. So if equals 0, no, actually, yeah, equals 0 because of the grep, of course. Master is not changed. Master exiting. So what we're trying to do here is we're trying to say, well, you just did a git pull origin, and I couldn't see any changes in git pull origin. So why should I bother with any of this other stuff? Right? And which then means that I will not bother to revert the commit, and I will not bother to build and regenerate. So the last commit would then be whatever we had there prior to this, right? So now let's have a look at what we see here. So you see we have a generated code and revert generated code. Now the reason why I have this pair is because when we started with generated code, we had no other way to determine what happened here. So what I'm going to do instead is I'm just going to say, take me back to here. And hopefully Git is going to be really clever. Right, now remember we did this timestamp business. So let's just stage this 393,000, 4,000 files. Not something you want to do within my Git, really. And then let's just create a stash for it. Right, so now then, we are now in just generated code. Now, remember, we can't just be faffing with this without seeing what generated code looks like here. So here as well, we need to revert to generated code. And then again, same thing. It'd be better if you could just actually discard commits, wouldn't it, really? Takes a while to stash 4K files. only to discard the stash really. It's silly. Right, so now our master branch is where we want it to be, and our local generated code is where we want it to be. So now what we want to say is, we want to say, well, do you know what? Let's just keep these two things open because we keep jumping from one to the other. So now let's do a test where we say, detect that nothing has changed, right? You're already up to date. Don't bother. Okay, that's good. Now, let's jump over to master again. And in master, what we're going to do is, we're going to say, now we must make sure we don't do a breaking change, but, so I'm just going to say here, fix me. Okay, so master has changed. We jump over to our shell, and now we run the same code. Interesting. So that is actually quite interesting. Did we really change master? We have changed master? No, we did not change master. So this is where you have to be very careful when you start faffing around here, because you are not the master. And the whole premise of this is that you must know what you're doing. It's not a very clever system, and it's only designed to work under very, very limited circumstances. It's a model of reality, really. But good. So most interesting. Right, okay, with all these changes we seem to have borked the code, which is peculiar. It seems that our revert, okay, so this is very interesting. It seems that our revert's actually not actually reverting correctly, so we have the generated code. But now we should have a revert to generated code. No, we don't. So see, what happened here now is we started off with generated code, we never reverted generated code, we merged master. Something has gone very wrong here. We should have started by reverting. So why did we merge before reverting? That's very, very worrying. Shouldn't have merged before reverting. So we did a pull. And we decided then not to revert the commit. Now that's interesting. Why did we decide not to revert the commit? But it's very interesting. Okay, we need very carefully to see what happened here, because really what should have happened is it should have been yeah, we should have reverted the commit. Okay, this is a bit worrying. Let's just try to get ourselves back in time to revert to the commits, discard all these changes, and see why this chap thinks not reverting the commit was the right thing to do. Oh, I think we forgot to do the 2 and 1. No. No. So this is just basically because we keep using this commit message without having that variable in our shell. Right, okay. So as you can see here clearly, we should have picked up generated code. we have to look at this very carefully. First thing is, let's just make sure we're not actually running any of this code. And so this is a bit rambly, but I think it's important for you to see what really happens in reality. This is the kind of thing we do with every other day, especially when you're tired and it's been a long day at work already. The brain is struggling to focus. Now this guy's convinced there's no need to revert the commits. So I would have thought this would... But look, we are... okay, right, so I think what's happening here is we did a git pull origin master into the generated code. See, this is the problem. So the first thing we need to do here is git branch master. Okay, because I think what's happening here is that we are actually in master. We're actually in generated, apologies, we're in generated and it's assuming we're in master. Git checkout, sorry. Oh, that's slightly more puzzling, so still attempting to merge. It's most peculiar. Why are we merging master? It's actually quite a complex thing to do. I'm beginning to think this is not the right thing to do this. It's a state machine with about 5 or 6 different permutations. These are quite complex permutations, so it's going to take us a very long time to stabilize this. So what we're going to do then is more or less call quits to this, really. So first thing is we seem to have lost our branch as well. Wow, we seem to be in a bit of a mess at the moment. Okay, so let's try to... This I believe is the generated code commit. Right, this is actually really, really hard. Seemed like a really simple idea, but actually the more we keep going, and we are already at almost 11 o'clock, so it's almost time. Well, we had to experiment with this. We had to figure out how hard this was going to be. Apologies. Clearly this is not the right way to do this, because it's going to take us a very, very long time to get this right. And it's going to be very brittle. We're going to have a lot of problems where it's actually just a git merge issue, and it's actually nothing to do with generated code. Which is really not what we wanted. The more noise you got, the more useless things are. Right, so at this point we just have to start to think out the real solution. Okay, cool. What we're gonna do then is let's just leave our code in a decent state. Turn to master. Get rid of all the annoying things we've done here. We look at the real work. Right, so let's just write some conclusions here. Something like notes. We tried implementing this approach, but there are lots of possible states and branches can be in, and it's very difficult to create a script that copes with all of permutations. I'll just leave that as our notes. Sadly, this is what happens sometimes. You can spend a lot of time and then not progress very far. Scripts work on creating a generation scripts for notice. And now what we need to do is we need to make sure, well, actually we're just going to do one more thing before we go, which is let's just have a quick look at these Travis files and say we don't really want to allow any more failures. Travis, remove do not allow for any failures. For Windows, interestingly, we are allowing failures in MSVC. Now, just to be sure, what we were saying a second ago was that we are not expecting failures on Dogen itself. Well, we had that failure here, but we don't quite know why that failure occurred, so we're going to remove these as well. Interesting. I think we have to remove the whole thing. Just commit this in one go, so up there, Travis, not allow for any failures. Well, that looks good. So we can just merge that into our master branch and push. That's fine. And then if we just do something similar in the ref impl, so let's just remove these here. I mean, we didn't remove the matrix statement, did we? No, that's correct. Okay, cool. And yeah, for these ones, we do have the expectation that we're failing on MSVC. And there's a reason for these failures, although we don't understand exactly why, but so for the upway, we'll leave it as it is. That's one for another day. If I just merge and push. Oh. Okay, right. So what we've done here is we forgot to pull before we pushed. And that's obviously causing problems. So what we'll do is we'll just stash this, pull, get rid of all the stashes, drop all of this, get rid of all of this, commit, raise also for master, merge and push. And now everything should be up to date. So, okay, not a particularly successful day, but like I say, it's important to have days like this, so you understand the reality of the developments. We have a lot of that. We have to experiment a lot. Sometimes even the simplest approach turns out not to be that simple, and we go back to the drawing board. That happens a lot. So that's all for today. Thanks for watching.